All right. Guys, yesterday we were talking about this idea of quadratic formula used to solve quadratics in standard form. Guys, primarily that standard form needed to equal what value?
0.
0, exactly, Gage. Now, another core concept right here is called determining the number of solutions. And I'm going to write this word down here. You're going to be looking at here's the word, discriminant. Okay, so for instance, the discriminant is the part that's underneath the square root sign. So what part of the quadratic formula is underneath the square root sign? What part is underneath the square root sign here, kid? B squared minus. Okay, so there's three cases that happen right here, kids. B squared minus 4AC can be greater than 0. Okay? B squared minus 4AC might equal 0. Oh, there we go. And then B squared minus 4AC might be less than 0. Okay? Guys, all this is saying is this. They're saying you're going to get some value underneath the square root sign. Now, when B squared minus 4AC turns out to be, gosh, if it's greater than 0, what kind of value is that? Get a positive here, kids. Then there will be 2 solutions. When I tell you B squared minus 4AC is equal to 0, well, guys, what's the square root of 0? And 0 is only how many answers? 1. So if the B squared minus 4AC is equal to 0, then that means you will have 1 solution. Anybody want to guess what the third box is going to be?
No solution.
It's going to be no solution here, okay? Because you're talking about the discriminant being a negative, and we haven't talked about how to handle the square root of negative numbers yet, so we would just simply say there would be no solution. Okay? I want to make a little sketch of what's really going on with these here so you understand. So here's what I want to do. Okay, so when we talk about quadratics all the time, we always get a U-shaped graph. Guys, if your discriminant is going to be a positive value, you would get a graph that crosses the x-axis how many times? Twice. Okay, that's going to be the condition right there. Your graph will cross the x-axis twice if the discriminant is positive. Graphically, if we have 1 solution, you may have a parabola that just comes down, touches the x-axis, and then takes off this way. And then it intersects on how many points, kids? 1, with that 1 point being the vertex. Good. Guys, no solution. Is the parabola ever going to cross the x-axis? No. That's kind of what's going on there. Okay? So that's a good visual for what the discriminant is really telling us. All right? So the discriminant says, well, how many solutions are there? And you're like, well, I don't know, but if the discriminant's positive, there has to be 2. Or if the discriminant's 0, there has to be 1. Or if the discriminant is negative, then there is no solution. So let's check this out. Let's check this out. It says determine the number of real solutions. If they ever say determine the number of real solutions, you're just basically evaluating B squared minus 4AC. Okay, so determining number of solutions, kids. What's the B value in that standard form? And maybe I should take a time out. Is it in standard form?
Yes.
Is it equal to 0? So can I start assigning A, B, and C values then? Absolutely. What would B squared equal, kids?
9.
Yeah, B is negative 3, isn't it? So B squared would be 9 minus 4 times, what's your A value? Times C, which is negative 1. Well, you help me. What's 4 times 2, kids? 8 times negative 1 is? So isn't this 9 minus negative 8? What's that equal, kids?
17.
Positive 17, right? Guys, is the discriminant a positive value, 0, or a negative value? Since the discriminant is positive 17, then how many solutions must there be? 2 solutions. So I'm going to say since b squared minus 4ac is positive, there must be how many solutions, kids?
2 solutions.
Exactly. Very good. Is this making sense, kids? Give me some kind of verbal, yay or nay.
Yes.
Yes? Okay. I thought you were going to say nay, and I was going to say, oh, the horses are out. Oh, darn. Come on, that was good for a Friday the 13th, right? And appropriately, Friday the 13th, we're all wearing a mask.
Wow. Such a nice Friday the 13th.
It's getting better every day, isn't it? The last Friday the 13th was the day we closed down. All right, friends, here we go. Next, guys, what's the problem with this determining the number of real solutions to begin with the equation? Is it set up to just go ahead and proceed, or do we have to manipulate it somehow? What's the problem? Not equal to 0. So I should probably move this x out of here on the right side. So what do you maybe want to do to rewrite this first? I'm going to subtract x from both sides. Okay, let's do that. Kids, check it out. This becomes x squared minus x plus 4 is equal to what then?
0.
Okay, so b squared, this would become negative 1 squared minus 4 times, what's the a value?
One.
1. What's the c value that I'm going to plug in?
4.
Okay, check this out. What's the negative 1 squared, kids?
1.
Okay, 4 times 1 times 4. What is that? So we're going to have 1 minus 16 here, aren't we? Help me out. What value is that? Negative 15. So in regards to the solution for our discriminant right here, since we know the discriminant's negative 15, what's that going to tell you about the number of possible solutions in this equation? There are none because the discriminant's what kind of a value? Absolutely. Okay? There are none. Okay? No solutions. Excellent. Okay? So guys, when I start saying determine how many, there's a difference between what we're doing. When I say find the solutions, you're doing the whole formula. But when I say determine how many they are, you're only looking at part of the formula. And what's the name of that part of the formula? What do we call this part of the formula? The discriminant, okay? So down here, this next thing, kids, I want to have you do the same thing here. This here says find the number of what, kids? Basically, the x-intercepts are like the solutions of an equation when it's equal to 0. So what you're really looking at is the discriminant for this. So find the number of x-intercepts of the graph of y equals 2x squared minus 4x minus 3. It's not telling you to find what they exactly are. They're just telling you to find how many, right, kids? Well, guys, what's the value of y at the x-intercept? Okay. I want you guys to see what the discriminant is and tell me how many solutions or x-intercepts there will be in this case, all right? So you take a minute and try that on your own. So am I looking at the whole quadratic formula, or am I looking at just the b squared minus 4ac part? Which part am I looking at if I'm determining how many? The discriminant part. Good. Okay, see how many solutions this is going to have, or how many x-intercepts, if you will. All right, kids, let's talk. We're looking at how many x-intercepts or how many zeros this will have. So if we look at b squared, if we look at the b squared minus 4ac part, what's b squared going to equal, friends? 16. Yep, negative 4 squared would be positive 16, wouldn't it? So we're going to have 16 right here. Minus, all right, what's 4 times 2, kids? 4 times a, in other words. 8 times the negative 3 here would be negative 24. Guys, when you subtract a negative, this really becomes what operation? So 16 plus 24, help me out, friends. Is that 40 positive? Is it equal to 0, or is it a negative? Since the discriminant is positive, that would imply there's how many x-intercepts then? There must be, how many x-intercepts again, Andrew? 2 of them. There must be 2 x-intercepts here. Okay, give me a show of hands. How many are on board with me with this idea of discriminants right now? All you're trying to evaluate is the b squared minus 4ac. It's just that one part of the formula under the square, so if they ask how many solutions. Now if they say what are the solutions, then do you do part of the formula or the whole formula? Then you've got to do the whole formula. Okay? All right, questions to this point? Okay, I want to see where we're at with this before I try a quick quiz here. It says choosing a method to solve each equation. All right? Guys, how many of those equations are in standard form up there? I don't want you to lose sight of some of the things that we've done. I look at this first one right here and I think, ooh, I have no idea. Can't factor this, so I would probably go quadratic equation on this. So let's list our A, B, and C values here, kids. What am I actually using for this one? What am I going to use for this one? Quadratic formula to solve this, okay? What's your A value?
1.
B is? How about C? Now I thought it was a good idea to go through yesterday on that chart. On that chart there, we then said, it'd be a good idea to know the parameters from the quadratic formula. So I think it's a good idea to know what b squared is. Or I'm sorry, the opposite of b first. I think it's a good idea to know what b squared is equal to. I think it's a good idea to know what 4ac is equal to. And I think it's a good idea to know what 2a equals. Because those are all parts in your quadratic formula. So what would the opposite of b yield for us? 4. How about b squared then, kids? 16. And then this is where I get hung up a little bit. 4 times a times c. 4 times 1 first is 4, isn't it? What's 4 times negative 7, friends?
Negative 28.
Perfect. Negative 28. How about 2a?
2.
Okay. So looking up here at the ink that I have on the left of the board here, which by the way, if you want to take a picture of that, I'm going to copyright it. I'll let you have it for $1.99 today for each download. All right? How many are going to buy that today? Oh, good God. Are you serious? I have to go hungry again this weekend? Aww. I still say that would look good above a fireplace, wouldn't it? Okay. Sam, you're looking at me like I'm kind of crazy and weird.
You are kind of.
Okay, at least you're telling the truth. What's the opposite of b going to be, that first part, kids? 4 plus or minus square root of b squared, which is what? 16 minus 4ac, which is minus how much? Negative 28, perfect, all over 2a, which is what, kids? Right?
2.
All right, so this is where I need your help right here. That's 16 minus negative 28. I know that turns out to be 44, but guys, is 44 a perfect square? No, and as 44 is not a perfect square then, what we need to consider is that we're going to have something that's irrational. How many places did we decide on yesterday when we did roots of numbers that weren't perfect? Okay, so square root of 44, what do you guys come up with? 6 point. So this becomes 4 plus or minus 6.63 divided by 2. All right, let me make some room in here so I can finish this up. Oh no, I missed. That's why I don't coach basketball anymore. First year of not coaching basketball, and I can't tell you how many years. Huh? I used to coach with Mr. Driscoll for a lot of years. Now they've got someone that's new and younger and nicer probably to help.
I bet not.
Oh, I don't know about that. What's 4 plus 6.63, friends?
10.63.
Somebody take 10.63 and divide it by 2 for me.
5.31.
I'm going to call about 5.32. Is that okay? Guys, 4 minus 6.63 then is negative 2.63. What's negative 2.63 divided by 2? Negative 1.32, right? Okay, so guys, probably the best way to solve that one, we notice it's in standard form. We said, well, standard form equals 0, probably use what? Quadratic formula. Now, same thing over here. You remember how to factor? We could take 10 times negative 12. We could do all that stuff with the sum product calculator again from last chapter. We could factor this whole thing out. I still think that this is shorter right here. If you can just plug stuff in and go that route, isn't it? Okay. Now, guys, don't lose sight of something like this. Is this even in standard form? Couldn't I solve this just using square roots like we did in the last section? Couldn't I square root this part right here and square root this right here? Guys, help me. Don't lose sight of this right here. What would I have on the left? What's the square root of 64?
X minus 2 is 8.
Plus or minus 8, right? So we'd have to set x minus 2 equal to positive 8 first. You would also set x minus 2 equal to what else? Ah! I would set x minus 2 equal to also equal to negative 8, right? Add 2 to this, what's one solution? 10. Add 2 to negative 8 right here, what's another solution? Okay. Guys, really the concern that I have there, are you able to differentiate between what methods to use when you see these quadratics now when we have to solve them? Are we cool with it right now? Okay. What would you probably use right here? I'm not going to do this one, but what would you probably go quadratic right there? Okay, so I think you guys have this down pretty well right now. So what I'm going to do right now, kids, is this. Let me find the recorder. We'll shut this down. Get that loaded up there. Kids, I do have a short, quick quiz for you today that I want you to complete.